This video is a very quick primer on imaginary numbers. We will learn a lot more on imaginary numbers later. First thing that you need to know about imaginary numbers is that they're not something to be scared of. It's just that when they named them, they already had things called the real numbers, and so they ended up calling these imaginary numbers. But ultimately, they're not really that scary. Imaginary numbers are basically just numbers that don't exist inside of the real number line. The number one imaginary number that you would notice is, for example, the solution to the equation x squared plus 1 equals 0. Clearly, there's nothing in the real numbers that makes this work because x squared is always going to be 0 or bigger. And there's no way that I can have something that's 0 or bigger plus 1 equals 0 in the numbers that we already know about. So because that's true, mathematicians developed these other things called imaginary numbers that help us solve equations in other ways. So remember, if we have y equals x squared plus 1, if we graphed that, we would have the graph of an equation that looks something like this. Our y-intercept would be 1, and we would have a parabola that opens up. Notice that there are no solutions to the equation x squared plus 1 equals 0 because we never actually hit 0. So we have no real solutions. But what ends up happening is if we have, for example, x squared equals -1 by subtracting 1 from both sides of the equation, and we take the square root of both sides, we get x equals plus or minus the square root of -1. What we end up doing if we have the square root of -1 is the square root of -1 we are now going to call I. So this equation will have answers x equals plus or minus I. You don't really need to know much more about it while we're doing these types of factoring problems, other than anytime you see the square root of a negative number, you need to put I. So for example, let's say we have 0 equals x squared plus 9x plus 29. That doesn't look like it's factorable. 29 is a prime number, and there's no way that I can get this to factor into something that has a 9, so I would likely either complete the square or use the quadratic formula. So if I want to use the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2 times a. So x ends up equaling -9 plus or minus the square root of 81 minus 116 all over 2. 81 minus 116 is -35, I believe. So I get -9 plus or minus the square root of -35 over 2. What we would do is we would get this answer, and then we would just rewrite it where we have x equals -9 plus or minus I times root 35. So notice that if there's a negative number on the inside, we just take negative square root of 35, or I'm sorry, square root of -35, and we say that that's equal to I times the square root of 35. So anytime you see a negative on the inside of the square root, we just change that to I. Now notice that in this one, root -1 is equal to I times the square root of 1, and the square root of 1 is just 1, so that's why it's I. Another couple examples real quick. The square root of -9 is going to be 3I. The square root of -12 would be I times the square root of 12, and the square root of 12 is 2 root 3. So we would have 2 root 3I. Those are another couple examples. You don't really need to know too much more about it, other than you just need to take I's out whenever you have any negative number on the inside of the square root, and we will talk more about that later in the unit.